Tonight, we go back 4.6 billion years, before there were planets, before there was Earth. Our story begins inside a massive, cold cloud of gas and dust floating in space. Slowly, gravity pulled this cloud inward. And as it collapsed, something important happened. The entire cloud began to spin. This is a rule of physics called conservation of angular momentum, the same reason a figure skater spins faster when pulling their arms in. As the cloud shrank, the spin increased. Faster and faster. Eventually, most of the material gathered at the center to form the sun. The rest flattened into a rotating disk around it, a cosmic carousel of dust, rock, and ice. And from this spinning disk, the planets were born. Every planet inherited its first spin from this original motion. But the early solar system was not calm. It was violent, crowded, and chaotic. Newly forming planets constantly crashed into asteroids, debris, and even other protoplanets. Each collision acted like a giant cosmic shove, changing how fast a planet spun, and even the direction of its axis. Some impacts were small and only slightly altered rotation. Others were so massive they permanently reshaped a planet's spin. Over millions of years, these random impacts turned what started as a similar spin for all planets into completely different rotations. What we see today is not the original motion from the birth disk, but the final result of countless ancient collisions. Most planets spin in the same direction they inherited from the original disk. But one planet breaks the rule. Venus rotates backwards. Its sun rises in the west and sets in the east. Scientists believe this strange retrograde rotation may be the result of a massive ancient collision that flipped its spin. Others suggest powerful tidal forces from the Sun and Venus's thick atmosphere slowly reversed its rotation over time. Whatever the cause, Venus is proof that a planet's spin can be dramatically rewritten long after it forms. The Venus spins strangely. Uranus goes even further. Uranus doesn't just tilt a little. It lies almost completely on its side, with an axial tilt of about 98 degrees. This means it effectively rolls around the sun like a barrel. Scientists believe a massive, Earth-sized object slammed into Uranus early in its history, knocking it over permanently. Today, this extreme tilt causes bizarre seasons, where parts of the planet face the sun for decades at a time. Uranus is a reminder that in the early solar system, even entire planets could be tipped over by a single colossal impact. Not only do planets spin in different directions, they spin at wildly different speeds. Jupiter completes a full rotation in just about 10 hours, the fastest day of any planet. Meanwhile, Venus takes longer to rotate once than it takes to orbit the Sun. A single day on Venus lasts longer than its entire year. These differences come from a mix of size, mass, and the history of impacts each planet experienced. Bigger planets like Jupiter retained more of their original angular momentum. Others, like Venus, had their spin slowed dramatically over time. Collisions were not the only forces shaping planetary spin. Gravity, especially from moons, continues to change rotation even today. Here on Earth, the pull of the moon creates tides in our oceans. But those tides also act like a brake. Over billions of years, this tidal friction has slowly reduced Earth's rotation speed, making our days longer than they once were. The same gravitational effects can lock moons and planets into fixed rotations, a process called tidal locking. Spin is not just a memory of the past. It is still being shaped by gravity right now. When we look at how each world spins, there is no grand design. Every planet is the outcome of random impacts, inherited motion, and billions of years of gravitational influence. The solar system did not form in neat order. It formed in chaos. And each planet's rotation is like a fossil record of that violent past, preserved in how it turns today. The planets don't spin differently because they were meant to. They spin differently because of collisions, gravity, and pure cosmic chance. What looks like a perfectly organized solar system is actually the result of billions of years of beautiful accidents.